the University of Southern Mississippi and anti-child porn organization, now incorporated. At this point, I'll probably have to say that the University of Southern Mississippi has the greatest IT department and computer science program. I have to say that now. Can you hear me? Alrighty. Again, my name is Tim Lawless with the University of Southern Mississippi and anti-child porn organization. I'm here to talk about a little project I've been working on, St. Jude, where we're trying to detect improper route transitions. Come on. Wake up. There we go. Of course, the computer thinks it's a Monday too. Actually, no, Star Office. Really happy with this version. This is my email address, and we'll be dropping this presentation plus other information out on this URL a little bit later on today. And St. Jude really came about because in our institution, we have to allow clear text passwords on a lot of systems, which, as you know, is the most evil thing that one can do. And once you get in, it's just a matter of time. So we started looking for a way to save ourselves a lot of time from sleeping on the floor. One thing led to another. A guy put forth an idea back in October, I believe, of '97 in System In magazine about actually trying to detect the transitions into the root user by monitoring audit trails under Solaris. That's really where we got the beginning of this, and it's come forward. The reason why we had to go and start looking at things like this is because our firewalls really would not protect us. We also, with clear text passwords coming in, our users themselves will expose our systems. They're sometimes our best friends and our worst enemies. As they would, the misuse detection scanners like Snort and the like really would not pick up everything. We've already seen how they can be bypassed, how the systems that we're putting out on our host really themselves can be defeated, and you will see this continually through the day. And of course, we've come to love our Unix vendors. That's the ones who give us new root exploits in every update that they send out. And we also, the problem also with our detection is that you may go 1-2 days without finding it. Unfortunately, system admins will go on vacation. And the longer that is, the more damage will be done to the system. But anytime that they're on the system, we can't trust anything really on the system itself. So that's where we began. When we began the project, we wanted to produce ultimately a kernel-level IDS implementation. Our target was Solaris, but we went over to Linux because it was easier to do development. There was a little bit more information just to get the wheels going. Pardon? I can't. We also wanted to try to minimize the number of false positives that we would be getting, and of course, the negatives. That was a problem with the original implementation put forth in sysadmin is a heap load of false negatives. Before we would be able to really respond to anything, we want to reduce those false negatives and false positives to a point where we won't shoot our users, plus we'll be able to catch enough of what's really going on. So what we were doing, we used a reference monitor implementation. I believe you'll probably hear a little bit more about this later on this evening when a gentleman talks about penetrating B1 systems. We also went to a rule-based anomaly detection. In just a moment, I'll go in a little bit more about that, and modeled behavior for execution after reviewing copious BSM outputs. Now, before we get into this, I'll go into a little bit, we're going to talk about subjects and objects. How many here have dealt with maybe trusted operating systems? Yes, no? Good. Excellent. So you'll follow what I'm saying. The subjects are the things that do things onto other things, while the objects are those which are being done onto. A little bit better definition is put up there. We'll also sometimes see that our subjects will be the objects themselves. The reference monitor will be enforcing our policy by forcing all actions performed by the subject to actually go through it. It will act sort of as a stopgap to prevent things from occurring which we really do not want to occur. The rule-based anomaly IDS, as opposed to our statistical anomaly IDS systems, given a rule set, if looking at a chain of events, we'll start off with the beginning where we'll enter the rule set and we'll move forward. If at some point one of the options at that point is not actually what is occurring, we have an anomaly going on. That's really what this guy's about. It was implemented at LLNL and the Wisdom in Sense, and also the TIMS project with Digital Corporation. Let's see. And what we're going to be doing is looking at, we take every subject or process in our case, we would classify it as being a privileged or unprivileged process. The privileges will be root, but it also may be a set of root plus somebody else. This would allow us to detect transitions into, say, Oracle users or other daemons that we're running within the system. Unprivileged subjects, just normal user processes, will transition up, like we know, through execution of the set UID binaries. In doing so, we then have to catch them and determine how they're beginning, where they're beginning in that chain of events that may then occur. The privileged subjects, processes, will drop their privileges through in Linux, one of these three calls. I believe under Solaris we'll be dealing with fourth one. Given a subject with privilege, and this is really where the decision is made, they may execute any other file in the system to exceed only if the subject first drops its privileges through one of the means we just talked about before, and the object is within the subject, or the object is within the restriction list within the rule base. A subject without privilege may execute any object. Just a normal user may go about his daily life. As long as they do not transition up into a privileged state, we're going to be perfectly okay and allow them to do what they want. Now, upon execution, we're going to have to do some stuff and juggle around, change our states, where once upon execution, the new subject's restriction list will be updated based upon the subject's prior state and the objects executed. I'll show you in a moment where we go through and have to say we're running a binary. He calls another function and he's okay to execute. We've already passed that on. The binary will then find the best rule, and we have to ensure that the next rule for what the next guy that's about to run can do is a subset of the current process's rule. Otherwise, we could gain privileges just merely by executing a certain path of applications. And finally, a subject's data restriction must be subject of the subject's prior restriction list that we just went into. This is currently where we're standing right now. We've got a Solaris Perl implementation. It'll run currently under Solaris 251 through 8. 8 has some problems with its arguments where it will not give those out to us in the BSM. It's not yet been fixed by Sun Microsystems. And the current Linux implementation is running, at this time, not on a multiprocessor system. We do not use argvs for context in the Perl module at this point, but under Solaris, under the Linux kernel, we are using the arguments to decide our context. The reason this being is some applications will make a call to system, for example, which goes out there and will run /bin/sh with the -c, and then the argument passed to system as the third argv, argv to the third argument. Without being able to look at our argvs for the context of what we want to do, we would then just have to allow these programs that are executing a system call to then just go merely out and run in the shell, which is something bad. We're hoping to have an internal Solaris implementation out by around Christmas of this year, maybe early 2001 at worst. Probably in the 2.7, Solaris 7 kernel, 8.0 if at worst. And just to show you, I'll switch the slides, I'm sorry. Externally, internal versus external, inside or outside the kernel. When we would do this, to be able to really stop the things before they occur, we would have to do it within the kernel to preempt them. However, when we go into the kernel, some things change. Externally, when we get them out through our audit trails, each event is a discrete instance. One line is one event. We have all the information about what's going on, while inside the kernel, we're watching it as it's actually going on. Sometimes we have to wait until another event occurs before we can just really determine what happened with the prior event. For example, with the execution of a setuid binary, the execution code down in the file system objects in the Linux kernel will actually set the UID and the effective user ID to 0 during the execution phase. However, since exec never returns, we never really know that a setuid binary has in fact been executed until another event occurs, and we can really see, we can infer from what has changed in the state of the system that it was in fact a setuid binary that went forth, and then we build our trees from there. Externally, the detection is delayed. In the Solaris implementation, we're seeing about 2-3 seconds on a single processor system. A little bit less on a multi-processor system, but at that point we begin racing to see who can kill whom first. Also externally, it is easy within those 2-3 seconds to script a kill of the external monitor. Within the kernel, it's a little bit harder. You would have to do it before actually doing an exec, which would require you to have the code within the module itself. For example, this little application will execute a bash shell. Give us, if it's setuid root, would give us root normally. Let me just go over here for a second. See, thanks. Normally, we're running this. We've dropped out to a root shell upon execution of the binary. However, going through the St. Jude model, the font, yes, sir. Just a second, please. I'm sorry. Let me. find a nice, this is good with fine. Maybe that'll work. Whoa. It did get big. Well. Okay. Let's try this one again. Normally, it would be dropped out to a root shell. Possibly. Is there... Normally at this point, your friendly administrator will spend the next evening, instead of with his wife and kids, rebuilding a system. What we want to do, I'm sorry, let me just, I'm going to go in here and load up the module. And then it catches the exec just as it begins. It kills it at the exec process, and we just drop out a message to our to our K-log. There are some... this would catch the buffer overflows. We've tried it with pretty much all the buffer overflows we could. I try not to keep many buffer overflow vulnerabilities on my laptop. I apologize, I'm nervous. You can tell.
Doing great.
Thank you. Let's see if I can just minimize this guy.
What other kind of tracing is there?
Right now there's no other tracing. When we're playing in the kernel, we're not outputting any tracing. There's some extra tracing in there depending on the compile time defines you do. But right now, the minimal ones will just make your hard drive rattle for several hours for just running an LS. It is feasible to add in additional tracing into the system, just modifying the source code of the main .c file. I'll get into the source code in just a minute. Let me find my window. I'm going to have to fast forward through these again, probably. Unfortunately, some things in Unix are not quite as good as they are in Windows yet. Pay attention too. I feel like I'm doing patches right now. Unfortunately, right now, there is no silver bullet. Not even this guy can really stop everything. He would be just another layer in there. For example, with the buffer overflow actually does occur. The shellcode does get executed. However, just at that execute is where it's caught and it stopped. That's why that's what it's referred to as the last-ditch effort right before hellfire and brimstone falls down upon us. Also, the restriction rules must be written. There's some applications, for example, I discovered when I came here, I have been spoiled all my life and have not used PPP yet, that the usernet CTL script causes that module to go really wild. So you have to go through and write out the rules in the script before it will before it'll not catch those and actually let them pass. Also, there's the additional overhead. As we're playing around within the kernel, just doing the extra stuff and munging the data, it costs a little bit. Just executing user processes without going through having to do any of the checks, we're seeing less than a 1% slowdown. However, let's say we're root and we're compiling a kernel, see almost a 5% slowdown at that point, and it's really spending it in system time now because we're having to update all of our checklist. There's really no optimizations in at this time. We do have some inline functions, but that's it. Now, the rule sets that I spoke of, that's the end of the slide presentation, I'm sorry.
Bring your website up when you're done.
No network connection right now. Sorry.
No, I mean just
Oh, yeah. Well, let me just hit that right here. Well, unfortunately, it's not PowerPoint, but religious reasons prevent me from using that. That's the contact information once again. Probably by 1 or 2 o'clock this afternoon, we'll probably have this PowerPoint out there along with the source code. The source code is available on PacketStorm at this time. Sent out an update last night. You got it? Good? Okay. Okay. Now, that will... Let's try to get this a little bit smaller. Much better. Can you hear me? Good. For example, right down here are the general rules that we've, the rule sets, and then unfortunately we're having to compile them in by hand right now, not read them at load time. We do want to be able to go to root sometimes, and so we're going to have some guys that really have to be granted a pardon. SU and sudo, by the way, sudo is bad, you should never use it, are in there. Gene Mixer was one that just had to go in there because it will execute mod probe through system as root. Otherwise, sound gets really loud and you can't turn it off. Are there any questions? Yes?
Obviously, if you're blocking SUID, would ping part?
Pardon?
Would ping part versus SUID?
No. As long a set UID process may execute. However, it may not execute other processes by default. The default rule down here is actually rule 0, which is none. You can really go through and execute nothing else. But that set UID process itself may execute. By granting all privileges, it has carte blanche in your system. SU and sudo, of course, would be applications where we'd want to do that. I don't think there would be anything else we'd want to do that for. Some of the testing that we did, just with a couple things, gets really long. Unfortunately, that's the nature of the beast right now for this guy. We're wanting to add in later support for just loading it in from a configuration file. Yes, right now it can. There is the option, and they're commented out for debugging purposes to prevent the loading of the unloading options. We just replaced the load and the clear module syscalls in there. Now, it is still possible to attack it through KMEM. However, personally using lids to prevent that, and maybe something put in this guy later on in the future. Pardon?
Were you going to policies? What kind of issue were you
Policies such as what we're looking at, what we were just looking at. Initially, what we'd have to go do is go through a learning phase where we just run through the system normally in a safe environment, not plugged into the network. We just hope we know what we're going to run on the system beforehand. After determining from the output of the learning process, which does everything but still permits it to actually execute, it just gives us the error message, and from those we then would be able to write these rules. Once these rules are populated, you've recompiled without the learning option enabled, you'd load that in and go from there. When you make changes to the system which may require these root execute features, you'd have to modify and go and reload from there.
How about external, when you have something distributed, how about externalizing? Different than someone that's just created, now you have to process that you want it. You just get a little dump of memory for that process and process.
Not through this guy. He's really he wraps himself around the kernel at this point. And in fact, now let me just go into. Since we can't link when we build a module to make it manageable, we've done includes. My C professor shit when he saw this. I think I committed a sin. And loading the module, this is just handling the execs, since I pointed you to the stuff by Pragmatic of THC for how to handle execs. But going down here, what we do is we're saving the original syscall to a pointer, replacing it with our wrapper, and within that wrapper we're going to make a call to that original syscall. So we just wrap ourselves around the kernel. We're not actually being invasive, and that's why we can actually pull ourselves out without much problem. Yeah. That would be possible. It would not be part of the module itself because it would be such an expensive process to do. Probably through a /proc file system interface with a monitoring daemon running, that you would be able to do that. I'm sorry. It was asked whether we would be able to, at some later point, modify this so that it would communicate and be able to attack the offending processes, offending users, processes, and pretty much retaliate against the login instance that may be perpetrating this. Would I be correct in saying that?
Basically be able to take the information for process ID and then do further gathering of what process is running, dump of the actual memory.
Dump of memory and just
Whatever you want to take from that.
that would be something we'd be doing in an external monitoring application, the dumping of memory and gathering of further information about the offending processes.
Part of being expensive, that will be executed while data has condition occurred.
Yeah, during the execs, forks, and to a much lesser extent, the set UIDs and exits.
I'm saying you can really include it in this module for memory, because it's not like this is something that ideally would happen. If this happens all the time, that's something really hard.
Yeah,
Just an idea.
yeah. I could see how it would be much easier to do it in user space versus kernel space, since a lot of the fun with viewing it in kernel space is you've got this, you're set right here and you're limited in what you can do. A lot of just string calls, you're going to have to write them yourself, since you cannot call external libraries while in kernel space. Plus, if you core dump in kernel space, that's a bad thing. Yes. We lost exec many times. Everything keeps running. Nothing else will. What was that? But after we load the functions and wrap ourselves, it just goes on. Right now we're allowed to clean up our module, we free our memory and go on. What normally we do to prevent you from cleaning up or loading in other modules is we just replace those with an error message of either for loading no memory or for cleanup module not found. And it just errors out and blocks any attempts to add or remove because those syscalls can be called from within, for example, a buffer overflow. Apache runs as nobody, so really you'd be hitting just running in user space at that point. If you're just without privileges, not root, we branch out just into the wrapper and go straight to the syscall itself, so that it's practically no expense if you're just doing user stuff. Named, let's say you're not running named as root. Just a moment on that, but let's say you're running named as root, and that guy was cracked. He could not really execute anything else after that. Maybe named expert would be the only thing he would be allowed to run. It would catch that. With one caveat, we still have a lot of the stuff that starts up at the beginning. We're still generating rules for that, and we're working on handling login, because login will sometimes transition over, be logged in root on console or login user. We're playing with how we would handle that guy right now. That'd be one thing that come out within the next 2-3 versions. The question was, what would be the load with like running this with an Apache web server? Other web servers, I have run this with Roxen without any problems. Just running regular CGIs. Unless I shoot myself in the foot by making an error in my logic. But yeah.
Why did you restrict yourself to transition?
We can go with a set of privileges, which root will always be the superset. Easier for just development. Right now, it's been root because that's been the parts where my headache personally came from, which caused me to really want to do this. I don't like sleeping on machine room floors. I asked why are we just limiting this to root transitions? Also transitioning just from user to user. Until you transition into that root user, you can have your other IDS utilities running out there as root with more privilege than that user, monitoring them, T2I Snoop, other applications, watching logs. But once they actually acquire that root privilege and they're in the system, you can no longer trust that stuff. So the only thing that has more privilege than root is kernel. Anything? Pardon? SU, well, right now, because the root, The question is, if you're using SU, is there anything to help? I'm not quite sure if I fully understand what you're... Unfortunately, right now, SU is it's a trusted binary to keep it more secure. If SU is, if you can root SU, especially on the Linux box, congratulations, man! Don't let anyone find out about it. You could own the world, literally. But yeah, sudo. I do it for convenience, but really SU would be the only one you really should have in there. And I hope SU is secure. I hope people have been hacking on it, trying to get it not to be secure enough. Yes, sir. Back in the back.
Your trusted binary table is storing the inode of the program, or
I'm storing the argument itself, not the inode. So moving around files on the file system would not affect it. It's a little bit, and I think you were probably going towards the LIDS project in that questioning. We're really not doing ACLs at any point in here. If /bin is SU could be replaced, yes. However, with proper, I hope the file system is set up properly, it should not be easily replaced without already having the privilege which you're trying to acquire. And then again, if they have physical access to your machine, you might as well just pack it up and go home. Pardon, sir? Copy a setuid binary. No, because we're actually looking at the file name as it's coming in through the exec, which is the fully qualified path name, not the argvia 0. The guy we were asking if, for example, you created a user bin under your home directory and would run SU under that, would that be it? Which I think you were trying to get at. If we were checking /argvia 0, you'd have relative path issues. Chroot. Actually, I don't know. I'd have to try that back in the hotel room.
Well, would it matter because your SU copy that you have would not have
That would be correct. You would not be able to give it setuid root privileges. So, you'd have to have a collaborating administrator. Or a negligent one. Right now, pretty much within a group, just the guys have been beating on it. A few other people would like to see what people could do to it. Yes, sir, right in the back.
I'd like to know if the machine is given to you in dark, and then you didn't know about it, and this module loaded after, did it detect transitions that were facilitated by dark?
The question was if NARC was loaded prior to this module actually being loaded onto this system, would it be able to detect the root transitions? If you tried to execute something, like let's say an LS or just a command through the system, it would catch that. If just any Trojan binary that just say anything, just not even that guy. If he did not have to call exec up to that point, it would not go through the reference monitor to be stopped or permitted through. Yes, ma'am. Yeah, right now, well, The question is why has symmetrical multiprocessor boxes been excluded at this point? At this point, we are not handling spin locks within the code, so race conditions probably would occur. That is something else to be going into. First, need to get a good SMP box that I can crash. Yes, ma'am? Yes, sir. Could you repeat that a little bit louder?
Multiple Metroid shell code, which would look like RP,
we're not using, let me just go into that and I'll show you, where is that? His question, if you modified argv of 0 to point to a legitimate file, would it be able to bypass it? And no, that was one that actually came up earlier on in the testing. What is it? Try scalls. We're not using the file name that actually comes in through the exec statement, which is really what is executed. That's what we're using for it to figure what you're going to run, yeah. Yes, sir. Well, if it is a buffer overflow.
In that case, my question is, if that's happened, there's already memory that's been overwritten.
That is.
How do you handle, let's say something really important is overwritten there, and you're handling that, or?
This guy, sorry.
I was looking for something called Sean Hedges.
Okay. Is there a Sean Hedges in this room? Sean Hedges? Okay. Thank you. Sorry. Could you repeat for me?
Sure. Let's use the example of a buffer overflow. It jumps to the shell code executes the your kernel logic attributes. What happens after that point to the memory that's been overwritten in kernel space?
The memory that's been overwritten is not in kernel space. The memory that's overwritten is on the stack at that point in time. You're not in the kernel memory at that point. You're still actually in user space. We try to terminate the process at that point. Exit the process. So literally just destroying the offending application, because after that buffer overflow and we deny the exec, it's not deterministic what will happen.
So that it's actually gets written into stack space, but then it does execute or doesn't execute?
The shell code will execute on a buffer overflow. It stops it at the exec itself.
Okay, so I might be missing something. In that case, would it be possible to replace normal shell code with something that would just unload this module and then run the same exploit with
You call the syscalls? Yes. In normal production, you would not have the unloading of the module. We would be overriding, actually replacing the syscalls for loading and unloading the module, or you would have to go through an attack kmem at that point, which... Yes, sir.
Sort of follow-up. So then, if you've got enough space to buffer overflow, write a shell into it, that shell would input that line. So that's how the holidays CPU day.
To run the actual shell, not the exec calls.
If you've got enough space to buffer overflow, that you can write a limit shell as opposed to calling.
The question is if you could actually just write a shell in the buffer. That was actually not the attack that we have recently been actually looking at, such as not so much writing a shell, but writing what you want to occur within the attack within it through, say, just to give you an example, one that we're trying to work on now is handling, you call open, open etc password in write mode, write out a new line, close the file. Probably even take up less space than what you're probably shooting at. At which point, that's where you'd bring in other applications, not a silver bullet, things like lids, where you actually be watching and protecting these files. Yes, sir.
So you're also not protecting against shackles and what from the instruction pause over bin is or something?
That would be something that we'd be doing actually in an external application.
No, you can write
I'm sorry.
shackles and whatever.
Pardon?
You could write a shellcode for one of those and rename /tmp/whatever.
Actually, would have to you would copy the binary over. Yes, but that's you would be wanting to. You'd be using applications like lids where you would be protecting the files themselves, your root file systems. Yes. And with it is 10:46, so if there are any other questions, I thank you for coming.